Hey everybody, my name is Tom. I'm joined today by Rohit.
Hello everyone.
We're both networking specialists, solution architects. So we meet with our customers on a daily basis to talk about the network architectures. And today's sessions is going to be on connecting your network, so your on-premise network, with hybrid solutions. This is a 300 level session, so a little bit more advanced, but we will try and recap some of the more basic concepts to get everybody on the same page. So if you've been into traditional networking and you've built networks, you know they can get a little bit complicated. Right? Building networks is complex. You got to figure a lot of things out. How you connect all of your sites, warehouses, data centers, branches, how much capacity you have to provision, how redundant you're going to make the network, what networking functions you got to insert and where. So it's tricky. And even though we have a lot of customers that are completely native on AWS, they don't have any requirements for hybrid solution. Still, a lot of customers have on-premise environments and still need to rely on hybrid. So our goal is to make that hybrid connectivity as easy and as simple to provision as possible. And we're seeing this transition with networking, where it used to be that AWS used to be a spoke on our customer's network cloud, where you can think about it as effectively as a data center extension. Now, AWS is becoming more and more a hub, a connectivity hub that's in the center of everything, and then the data centers and other environments become spokes. So we see customers start to rely more and more on the AWS network capabilities, and we'll talk about what they are. And this whole process, it's effectively a network transformation. So just like with digital transformation, you were moving your resources from kind of on-premise servers to virtual machines in the cloud, network transformation means you're moving a lot of your networking constructs into AWS and using and relying more and more on the AWS network. And to make it simpler, we conceptualize it into multiple pillars. So you can see the pillars right now. We have connectivity within AWS. So that's anything talking within AWS, maybe VPC to VPC. We have connectivity to data centers. So that's your AWS environments communicating with your data centers. Connectivity to branches, usually a lot more sites communicating back to AWS. And finally, talking out to the internet. So if you have environments that need to talk out to the internet, that would be the last pillar. And this is all underpinned with network security and running on top of the AWS global backbone. And I'll cover what that backbone looks like in a second. So in today's session, we'll spend most of our time on the two pillars in the middle: connectivity to data centers, connectivity to branches. I know Rohit will talk a little bit about connectivity to AWS at the very end, so that's going to be a little bit broader. But the main two pillars in the middle are what we're going to cover. So when you're deploying AWS infrastructure, you have a bunch of different options on where you can deploy that infrastructure into. Right? So normally, you could deploy your applications into 26 of our distributed regions. Each region is a district geographical location where it's split to multiple availability zones. Altogether, we have 84 availability zones. And then that's expanded by a layer of points of presence, which could be used for our content delivery network, DNS, or for Direct Connect to plug into the AWS network. Then all of those regions are connected with AWS global network. So it's a global network managed by AWS with multiple 100 gigabit Ethernet connectivity spanning the whole globe with the exception of China. And then on top of that, we have 100 plus AWS Direct Connect locations. These are the locations that you can use to plug into the AWS network and then use it to get to a region of your choice. And you can go beyond just deploying resources into the regions. You can bring AWS into your own environment, into your own data center using AWS Outposts. That's where you would get a rack or a server that's running the same APIs that you use to manage the AWS cloud. And you deploy that into your physical data center. So this is useful if you have very specific application requirements or local critical applications or data resiliency requirements. And the other option that's kind of the middle ground, so you don't have to deploy anything in your data centers, but this is effectively an availability zone that's closer to where your users are. So you can run your applications usually in large metros where you have a lot of users to improve their performance. And from a local zone side, we actually have a list here of 32 new local zones that we're planning to deploy, or some of them have already been deployed or are in the process of being deployed. And if we zoom into how a local zone actually looks like, and it's very similar to a regular availability zone. In this example, we have a VPC that's in the US West, Oregon region. This is a parent region for our LAX local zone, so Los Angeles local zone. And you can see the same constructs exist in the local zone as they do in regular availability zones. We have public subnets, we have private subnets. We have the ability to access resources through an internet gateway. And you can see in the diagram there's two internet gateways. There's actually one internet gateway in reality that you need to create. This just represents the fact that if you have users connecting to your local zone, say they are in Los Angeles, they would be connecting directly to the resources in your local zone rather than having to go through Oregon region and then back. And the same thing applies to Direct Connect. So you can deploy Direct Connect connectivity. This is private connectivity that we'll spend some time talking about in a second. Private connectivity into your local zone that you access directly without having to hairpin through the region. That said, out of the 32 local zones that I've shown you, only some of them have those Direct Connect capabilities. We are in the process of rolling out a Direct Connect access to all of the other local zones that you've seen on the previous slide. Okay, so let's start with connecting to your data centers. And data centers usually have very specific network requirements. They need a lot of capacity. You want to make sure they're highly available and resilient. So with that, we're going to focus on a bunch of services that can help you establish that connectivity. So you'll see a lot of the times we'll talk about Transit Gateway. You can think about the Transit Gateway as the logical router that AWS manages for you that lives inside of a particular region that allows you to interconnect VPCs in that region and then connect them back to on-premise using Direct Connect or VPN. And I'll spend some time talking about the different options we have on Direct Connect, and then Rohit is going to talk about Site-to-Site VPN and then connectivity to branches. Okay, so let's start with Direct Connect. And I'll show you a very brief overview of Direct Connect connectivity, and then we'll start splitting it up into chunks and diving into the different components. So at a high level, we have a couple of regions here. Each region has a transit gateway connecting to a VPC, or potentially thousands of VPCs. We have a Direct Connect location, which is a physical location where AWS has a router that's dedicated for this connectivity, and then you have your router potentially in the same location and your corporate data center back on premise. And then you establish connectivity to the Direct Connect location, and then from there to a construct called Direct Connect Gateway that in turn spans to these transit gateways. Okay, so there's a couple of components here. There's a physical aspect, right? The location, the physical connection. And on top of that, there's a bunch of logical constructs. The Direct Connect Gateway, the transit gateways, the VPCs, and the VLANs that I'm not showing here on the drawing. So let's start off with the physical side. So the first thing you need to do when you're getting a Direct Connect is figure out how do you want to get that Direct Connect. And we have two options. There's a dedicated option, and there's a hosted option. And the screen is split into top bit is dedicated, bottom bit is hosted. So in the dedicated connection, you as the customer go to AWS and say, hey, give me a particular port on a device. I need this speed. And you organize that connectivity. You can still use partners to help you extend like a layer 2 back to your on-premise. But in general, it's all your responsibility to set it up. With a hosted connection, a partner would already have equipment in our locations that connects to our routers. So all you do as a customer, you go to a partner and you ask the partner for delivering a particular connection to your location. So all you need to care about is just your location. And there are some differences. So from a dedicated standpoint, the speeds we support are 1, 10, and 100 gigabits a second. And there's also a larger number of virtual interfaces. I'll explain what virtual interfaces are. Just know on a dedicated connection, you have 51 of them. On a hosted connection, you have a lot more speed and throughput options. So you can start with a connection as slow as 50 megabits a second and then go up to 100, 200, 500, all the way to 10 gigabits a second. But you get only a single virtual interface. So if you need more virtual interfaces, you got to go to the pod and ask for another hosted connection, and then you'll be able to create another virtual interface. So today we'll spend most of the time on dedicated connections, so just assume from now I'm talking about dedicated connections. So with dedicated connections, it's on you to request the connection in the right location. So the next decision point is to figure out which location are you going to select for connecting to a particular region. So say your data center here is in New Orleans. One option to connect to a region in US East 1 could be to go through Equinix Direct Connect location in Dallas, or you could use an Equinix Direct Connect location in Ashburn. Usually the decision point is based on latency to the location that you're going to. So maybe in this case, if you care most about latency, you would select Ashburn as your Direct Connect location, and then maybe Dallas would be your backup. But you can also make a decision based on cost. So maybe you already have presence in Dallas, maybe you already have connectivity to Dallas, so you might prefer to pick that location, even though latency-wise, it's going to add a little bit of extra. So going on the physical path, the next thing you can do is configure link aggregation groups. So lag or link aggregation groups is a technology that allows you to pool multiple individual connections into a grouping. So in this case, in the example, we have 4 connections. Maybe each one is 1 gigabit a second. And you can pool them in a lag. So that means that now we have 4 gigabits a second of aggregate capacity that you can use to connect to the particular region. Just know from a resiliency purposes standpoint, we don't support multi-chassis lags. So always think about the lag as a single connection from an availability standpoint. Okay, moving on the stack, let's talk about encryption. So you may want to have encryption on top of Direct Connect, and we do support MACsec, which is a layer 2 encryption technology that allows you to encrypt point-to-point between 2 adjacent devices. And this could be an AWS router and your router in a particular location, or it could be an AWS router connecting back to your on-premise environment as long as there's a layer 2 extension back to that customer too in this example. So it's supported on 10 and 100 gigabit Ethernet connections, but not in all locations. So have a look at our documentation to see which locations support what technology. And then from that Direct Connect location, we actually do a hop-by-hop or optical encryption all the way back to the region. So we actually encrypt traffic between our secure facilities. So if traffic is leaving, say, one availability zone and has to go over a piece of fiber to another availability zone, and at any point that piece of fiber is under a road that AWS doesn't manage, we would encrypt that traffic. And then on top of that, so that's the base layer encryption on an optical MACsec level. There's an additional layer of encryption that you can add depending on what technology you use to interconnect things in AWS. So maybe you're connecting VPCs in different regions through inter-region VPC peering, or you're connecting transit gateways. They would add an extra layer of aggregate encryption for all of the traffic crossing the regions. And then you might happen to use particular type of instances that also have encryption enabled. So there's yet another extra layer of encryption. So if we start adding these up, we have the MACsec. That's one encryption option for Direct Connect. We always recommend that you use TLS for your application. So you have your application layer encryption all the way to the application or load balancer. And then there's a couple of other options that Rohit's going to touch on a little bit more. Is you can use an IPsec site-to-site VPN that runs on top of Direct Connect to add encryption. Or you can connect IPsec connection to an EC2 instance inside a VPC that you manage running a virtual router software of your choice or a firewall software. Okay, so that's the physical layer. Let's now start digging more into the logical configuration. So you decided on the location, you have your physical connection. Now you're creating virtual interfaces. And we have 3 different types of virtual interfaces. We have private, transit, and public. Think about them as VLANs. These are VLANs and an eBGP session. We have a naming convention in AWS. So depending on what you're connecting to, you would use a different type of a virtual interface. So a private VIF connects to a Direct Connect gateway and then can connect to up to 10 VPCs. So think about a private VIF as effectively connectivity to a VPC. Transit VIF connects to a Direct Connect gateway and then up to 3 transit gateways. So think about a transit VIF as a way to connect to transit gateways. And then finally, public VIF. Public VPN is when you're connecting to things that live outside of the private VPC space. So it could be services like a simple storage service, DynamoDB, NoSQL database, and so on. So each one of those, again, is a VLAN effectively and an eBGP session. And all of those support both IPv4 as well as IPv6 connectivity. So we can have a look at those different types of virtual interfaces on an actual diagram, showing you an example. So we have a physical connection, say it's a 10 gigabit connection. And then on top of that, we can create these different virtual interfaces. And if you remember, with dedicated connections, we have 51 virtual interfaces you can use. One of them can be transit with. The rest can be public or private. So the transit with connects to a direct connect gateway that goes to a transit gateway that goes to a bunch of VPCs. And you can have thousands of VPCs here. So it's a very scalable way of connecting to a lot of resources and not having to modify your connection as you add more VPCs. With private with, you connect to a direct connect gateway and then up to 10 VPCs. If you need an 11th VPC, you have to create another private with, another direct connect gateway that connects to another 10, and so on. So there's a little bit more overhead as you add more VPCs. So the question is, why would you use one or the other, right? So if transit gateway is so scalable and you can connect to thousands of VPCs per transit gateway and connect to 3 transit gateways over a transit with, why would you even think about private with? And the answer here is cost. So transit gateway adds a processing charge to the traffic coming in and out. So if you have VPCs where you're sending a lot of data, maybe you're doing a migration or have a VPC that's doing a lot of analytics and is receiving a lot of data from on-premise, you may consider having that VPC on a private with, and then majority of your VPCs could be on a transit with and transit gateway. Finally, public virtual interface, that's a VIF that connects to anything else outside of the VPC space. So all of those services on the diagram here live on an AWS public IP address, and you can connect to them over either the internet or a public VIF. So if we zoom in a little bit more and have a look at the IPs and routing on all of those different VIFs, for the public VIF, you have to use public IPv4 addresses on a point-to-point connection to establish your eBGP session, and you can use a globally routable IPv6 space that AWS can allocate for you. And then AWS will advertise all of our public address space to you over the public VIF. And you can apply some filters to maybe only receive a single region or a continent, or if you want, you can see the whole globe. So this means that you can have a direct connect location in New York and connect to an S3 bucket in Sydney. On a private VIF, the point-to-point address space is private. We're actually using local addresses here for IPv6, the globally routable address space. And then the prefixes advertised from AWS are all of the VPC CIDR ranges that you've configured on the VPCs, and you can apply a filter. So you can say, maybe I don't want to see some CIDR ranges being advertised. You can filter them out. That's optional. And then finally, for transit VIF, very similar to a private VIF, private IP space for IPv4, globally routable for IPv6. But this time, the transit gateway is originating routes. So instead of there being a filter, you're effectively configuring what routes transit gateway should advertise, regardless of what it has connected to it. And one thing you need to remember, there's a limit of how many routes you can advertise, and that is quite low, it's 20. So even if you have 1,000 VPCs, you have to be able to aggregate the address space to 20 routes, so it's really good to do a lot of IP planning in advance. In the other direction, from on-premise over private VIF and transit VIF, you can advertise up to 100 routes. So this is just to repeat the point I just mentioned earlier. With Direct Connect Gateway Association, when you're associating a virtual private gateway to it, the same configuration, so the configuration looks exactly the same. You'll see this allowed prefixes tab, and whatever you put in there for a virtual private gateway, so for connecting for a private VIF, will work as a filter. So filter what prefixes you're allowing. For transit gateway, this works as origination. So it will basically say, in this scenario, you're telling the transit gateway to advertise 10.0.0/16 without, it doesn't matter what other networks are connected to the transit gateway. Okay, so far, we really didn't have a lot of resilience in our setup. We only had a single direct connect location, and a single location is guaranteed, where a single connection is guaranteed to go down, right? We will have to do plant maintenance, software update patches, and if you have a single router, eventually that's gonna have to go through an update. So we always recommend think about resilience. And this is already a better setup using 2 locations with 1 connections in each location on a transit VIF. Same thing applies to private VIF and public VIF, but I'll spend mostly showing you transit VIFs. And then you can have a single data center in the back, or you can have multiple data centers in the back. As long as they have some interconnectivity, you're resilient. And then the ideal scenario for maximum resiliency is actually having 2 locations with 2 connections in each location. So any single thing can fail, and you still have a lot of capacity to get to your resources in AWS. And you'll notice all of these transit VIFs from different connections are landing on the same Direct Connect gateway. And you don't have to create multiple Direct Connect gateways. That's already a highly available construct, and it's not actually a device. It's just a configuration aggregation that goes onto existing equipment. So it doesn't change your resiliency. It actually improves how resilient you can get. So if we look closer at the availability, these models I've just shown you translate to roughly to the SLA. So 2 locations with 1 connection in each is 3 nines. 2 locations with 2 connections in each is 4 nines. There is some caveat about which locations are used for which region, so have a look at the SLA to read the fine print. But in general, designing for 4 nines is when you have 2 locations with 2 connections. And then again, single Direct Connect connection is not a resilient way to connect. Ideally, you want to have other Direct Connect connections, but VPN could also be a backup option that's sufficient, but we wouldn't recommend it for highly critical scenarios. Okay, so say you have those different connections, and now you want to do some traffic engineering. You want to influence which paths you want to use for which traffic. And it's very easy to do if you're advertising or influencing traffic from your data center to AWS, right? You control the devices, you control the routers, you can configure whatever you want to decide how the traffic gets there. It's a little bit more tricky to influence how AWS decides when sending traffic to your data centers. And there's 2 options you can apply for this configuration. You can do ASPath prepending or local preference, which is influence for communities. They're both BGP attributes that you can control. So in this scenario, let's say you're managing router Z and Y, and you have network A. And then router X, imagine this is AWS. So with prepending, what you're doing is basically from router Z, you're just advertising network A, and it's showing up with a single ASN, 65001. But maybe router Y, you've set up prepending, so you've added artificially an extra hop. So now you can see there's 2 65001s in there. So when router X looks at the paths, it will see that one path is longer than the other. It will prefer the shorter path and effectively select router Z as the preferred path to network A. Now with communities and local preference, the way this works is each router would send a community when it's advertising a route. And that community is something that's documented on our documentation page. You can look at what community maps to what local preference. But 7100 would map to low preference, 7300 would map to high preference. So when we receive those communities, we would configure our local preference on our end to say that traffic to network A through router Y has high preference, through router Z is low preference, so we prefer router Y. And if you configure both at the same time, the way BGP works is it will look at the local preference first and will ignore the path. Only once the local preference is evaluated, then it will look at the path. So if we configure that scenario at the same time, we would still prefer router Y here because that's high preference, even though it has 2 hops. So when you're setting this up on AWS, on your Direct Connects, use ASPath prepending for influencing traffic in the same Direct Connect location. So that's a scenario where you have one location, multiple links, and you're influencing traffic between them. If you have multiple locations, you've got to use communities that translate to local preference. So we can have a look at an example. We're back to our scenario with 4 links in 2 locations. Say the top router is advertising our corporate network, and it's applying community 7100. That translates to a low local preference on our end. Same thing happens for router 2. Router 3 is advertising the same route with community 7300, which will translate to high local preference, and a single ASN. And then router 4, also using high preference, 7300 community, but it's prepending the path. So it's pretending that there's an extra hop. So when the traffic is coming in, maybe from the region at the top to the Direct Connect gateway then will look at all of those attributes and it will see, okay, first of all, I'll prefer Direct Connect location 2 because it has higher preferences. And then I'll look at the links in that location and I'll see that one has 1 hop and one has 2 hops. So I'll prefer the one with 1 hop. Okay. Another feature of Direct Connect I want to talk about is Direct Connect Site Link. And this is something that we launched at the end of last year. And it's the ability for you to be able to use Direct Connect to interconnect your on-premise environments without having to go into the region and use any of the region resources. So before Direct Connect Site Link existed, this was the setup that you would see. So we're back to our 2 regions. We have a couple of VPCs. We have a virtual private gateway, Direct Connect gateway, private VIFs, all of the components that you're familiar with already. And we have 2 on-premise data centers, 192.168.0 and 168.1. And say we have something X in the top corporate data center that needs to communicate with Y in the bottom data center. Even if the routing was configured correctly, that traffic wouldn't be allowed. So Direct Connect Gateway would explicitly drop this traffic and not allow it to go through. With Site Link, and the configuration you can see is very complex, just a single tick box. You enable this on the private virtual interface or transit virtual interface, and what it will do is allow for those 2 data center environments to communicate. So now traffic from X can go to Y through the Direct Connect Gateway without having to touch the region. And it allows you to now build very creative and very interesting environments that allow you to interconnect your resources across the globe through Direct Connect. So here is an example where we have a few VPCs again in multiple regions, Direct Connect Gateway, and then 3 different locations. And these could be hosted connections, dedicated connections, it doesn't matter. All you need to do is create a private virtual interface with a site link enabled on it, and that will allow those those data centers to communicate. And you know that virtual interfaces are just VLANs. So if you need a separate VLAN, maybe for your non-production environment, right? So you have 1 VLAN, maybe all of these sites are connecting, and this is a production VLAN. You can create a second Direct Connect gateway. You can create a second set of virtual interfaces, and then configure connectivity between them, enabling site link. So these are 2 independent VLANs. You don't even have to have resources inside the region, and traffic will just take the shortest path from the Direct Connect location to another Direct Connect location where your data center is connected to. And this also applies on a transit VIF. So with transit VIF, the slightly different requirements, because if you want a transit VIF, your hosted connection has to be 1 gigabit or higher. But as long as you can deploy a transit VIF, you can also enable site link and allow those different environments to communicate. So again, this allows for very interesting architectures where customers have now started using the AWS backbone to interconnect their global locations, often as a primary way of connecting between those locations, or sometimes as a backup to their existing MPLS networks. And it's available today, except for China. China is the only exception. It's a separate network environment. So some best practices for Direct Connect before I hand over to Rohit. Monitoring your Direct Connect. Like any other service, you want to do your monitoring. And you can do kind of the usual suspects here. Monitor your packets per second, monitor your bits per second, and you can do it on a full connection basis, or you can just monitor the VLANs, the virtual interfaces. And then some other best practices, use a personal health dashboard to get notified about any plant maintenance that might be coming up on a Direct Connect connection. There's a blog post we launched recently about end-to-end monitoring. This goes into details of how you can run an instance inside your VPC that will monitor different endpoints and tell you that potentially some connections are not working properly. On Direct Connect itself, you can enable functionality called BFD, bidirectional forwarding detection. What it does is it speeds up how quickly Direct Connect can detect a failure. So by default, Direct Connect uses eBGP as the routing protocol, and it can take between 60 and 90 seconds to figure out something's gone down and it needs to flip traffic. If you enable BFD, and you can do that on a per connection basis, it can take that time down to less than a second to detect a failure and switch traffic over to a different path. Make sure you test your configuration periodically. You can do it from your end by shutting down interfaces. Make sure you schedule a maintenance window before you do that. But you can also set up a test through the resiliency toolkit. So Direct Connect has a feature now where you can go in and say, I want to disable a particular virtual interface or a connection just to see what's going to happen. And then make sure you have a backup, right? So single Direct Connect connection is not a highly available way to connect to your environment. You got to have a backup, ideally another DX, but if not, at least have a VPN. Okay. And with that, I'm going to hand off to Rohit to talk about Site-to-Site VPN and connectivity to branches. Rohit.
Thanks, Tom. All right, so let's dive into the connectivity options using Site-to-Site VPN. So this option is useful when you want to set up your connectivity from your data center to AWS in a quicker and a faster way. So let's start with understanding what are the connectivity options that you have with VPNs. So you have your corporate data center on the right, and you have your AWS Cloud and the region within that, and you are created a VPC within that. So now the first option is to terminate the VPN connection on the virtual private gateway. This connection goes over the internet by default. The second option is to run an Amazon EC2 instance within a VPC that runs your VPN appliance and allows you to connect from your corporate data center to AWS. The third option is to terminate the VPN connection on a transit gateway. And as Tom mentioned before, the transit gateway itself can connect to even thousands of VPCs. So you are simplifying your VPC to VPC as well as your VPC to on-premise connectivity in this option. And a slight modification of this option is to enable acceleration for site-to-site VPN connections that terminate on the transit gateway. In these options, as you can see, the option of the number 2, which is the VPN option that you're terminating on an Amazon EC2 instance, is something that is managed by you as a customer. So you are responsible for managing the high availability as well as taking care of all the other operations involved with that. Whereas the other options such as virtual private gateway and the transit gateway are managed by AWS. So we take care of the high availability and all the operations that come with it. So we'll focus on two options today, which is connectivity from your corporate data center to AWS, when you terminate the VPN connection on the transit gateway, as well as terminating on the virtual private gateway. So let's start with virtual private gateway here. So you have your corporate data center on the right, and you have created a VPC within a region. So you create a virtual private gateway. So when you do that, and then you create a VPN connection on top of it, you get these two public IP addresses that are denoted in the white color here. These two public IP addresses, you can then access it from your customer gateway device, which is running on your corporate data center. And as you can see, this connection goes over the internet. However, if you are already using a direct connect and have configured a public virtual interface on top of that, you can then run a site-to-site VPN connection on top of your DX. So think about your DX as your underlay that is carrying the traffic at that time. When you set up this VPN configuration, you have the option to specify whether you want to use a static or a dynamic routing for your connection. And for most complex networking cases, we have seen customers use like the dynamic routing that they can use. So we'll assume that we are going to talk about dynamic routing going forward. So in this case, the next thing that you do that is when you create this eBGP session, you will then see that you will have the inside IP addresses for your BGP session that will be used to carry the routing information between AWS and the corporate data center over the BGP. Now let's look at how the routing works. So on the VPC route table, you will specify the route pointing to your corporate data center. You have two options here. Either you can statically define the IP addresses or the prefixes for your corporate data center, or you can dynamically learn them by using route propagation. What that will do that is, the virtual private gateway, when it learns these routes from your corporate data center, it is going to install that into within the VPC route table. And then these routes will be learned back to your corporate data center, and then it can send traffic back to AWS over VPN. Now in this option, as you can see, when you create the site-to-site VPN connection terminating on the virtual private gateway, you are charged for the connection hour for your VPN, as well as the data transfer out charge from AWS back to your on-premises environment. Now in terms of throughput, you are limited to 1.25 gigs per second, and the reason for that is because when you terminate the VPN connection on the virtual private gateway, it chooses a single tunnel to send traffic from AWS back to your corporate data center. And there is no support for ECMP here. Now, as we saw that you got two VPN endpoints on the AWS end, which are highly available, that we launch within the two different availability zones. So you have the built-in redundancy on the AWS side. What if you want to now have a redundancy on the corporate data center side, which is what we recommend you? So what you can do is that you can create another customer gateway device 2 on your end and create VPN connections from that router, as well as from the customer gateway router 1 to terminate VPN connections on the same VPC. So as you can see in this diagram, there are multiple VPN connections from the two customer gateway devices going to the same VPC. So as you keep adding number of VPCs, you can see that you have to manage now more number of VPN connections. To help simplify this, you can use AWS Transit Gateway. So you'll have multiple VPCs that will be directly connected to your Transit Gateway as VPC attachments. And then what you can do is you can create the VPN connection that terminates on the Transit Gateway, which will be nothing but like a VPN attachment here. Same, you will get two public IP addresses on the AWS end. You will have two VPN tunnels that will be created as a part of that. And in terms of routing, what will now happen is that you will now point the VPC route table to say that I want to send all traffic to the Transit Gateway. Either that is for VPC to VPC connectivity or directly sending it back to your on-premises environment. Then at the Transit Gateway will have a route table that will say that, hey, I have routes for the VPN that should go back to the on-prem, and we will advertise the VPC routes to the on-prem as well. And then it will also have the VPC spoke attachment routes as well to enable VPC to VPC connectivity. And once the corporate data center learns these routes on the on-prem, it will know how to connect back to these VPCs. In this option, as you can see, you are simplifying the VPC to VPC as well as your VPC to on-premise connectivity, but there is an additional charge for using Transit Gateway, which Tom just talked about before. Those charges are nothing but the Transit Gateway attachment charges as well as the Transit Gateway processing charges. From a throughput point of view, you get two VPN tunnels and each of them support 1.25 gigs. Now the key advantage here that you see that with Transit Gateway is that you can have both the tunnels that can be used to send traffic back to your on-premises environment, and it supports ECMP. What that means is that you can now have different flows of your traffic on a per flow basis that can take two different VPN tunnels to go back to your on-prem. And if you are looking for higher aggregate bandwidth, what you can do is you can keep adding more VPN connections till you get that aggregate bandwidth. From a redundancy perspective, as it applies similar to the virtual private gateway, on the corporate data center, you will need to have another customer router that will act as a redundant, that will provide redundancy for your customer gateway device. Now let's do a quick comparison of the various options. So in case of the virtual private gateway, you can connect up to a single VPC. The throughput is limited to 1.25 gigs per second, and there is no support for ECMP. In case of when you are terminating the VPN connection on your EC2 instance, you still connect to a single VPC, and your throughput depends upon what type of EC2 instance that you are using to run your VPN software appliance. And the ECMP support also depends upon what vendor that you are using for your VPN software appliance. In case of Transit Gateway, a single VPN connection allows you to connect to multiple VPCs, and you get throughput of 1.25 gigs per second. And it also allows you to have ECMP support, provided you are using a dynamic routing when you are configuring your VPN connections. So as you are building your hybrid connectivity using VPNs and using transit gateways, there are some scaling considerations that you should keep in mind. One of the key considerations to keep in mind here is that the packets per second limit. So for your VPC, VPN, Direct Connect and peering attachments, we support 5 million packets per second. And for your VPN tunnel, each of that VPN tunnel supports up to 140,000 packets per second. Now let's understand what are the best practices for using a site-to-site VPN connection. So we recommend you to use Amazon CloudWatch to monitor your VPN connections. So you can monitor things like the tunnel data in and out of that, as well as the tunnel state, whether your VPN connections are up and down. And you can also create CloudWatch alarms to notify you when either one or both of your VPN tunnels are down. And as something that on the AWS side, what we do is that we provide you these notifications through your personal health dashboard when you have either configured a single VPN tunnel for your VPN connection, or if we have done some maintenance on your VPN tunnel endpoints, so we can notify you if there was any change made there. Some other best practices is that if your customer gateway device supports dynamic routing, you should use BGP for your VPN configuration. We also recommend you to use dead peer detection in order to failover between the two tunnels that you have used. And as a best practice, you should configure both of your tunnels for your VPN connection and test these failover scenarios. If you have configured a single VPN tunnel for your VPN connection, we will notify you about that. So far we have been talking about connectivity to data centers. Now let's dive into how you can extend connectivity from your branch offices to AWS. So throughout this session, we have talked about various options such as AWS Direct Connect, your site-to-site VPN connection. Those can still be used to extend connectivity for your branch offices. However, in case of Direct Connect, if you are using that, it may be that your branch offices may not need as much performance as the Direct Connect provides, right? So what we have seen is that the VPNs are using an SD-WAN is a common approach that we have seen our customers use. So in case of site-to-site VPN connection, as you can see, when the traffic leaves from your branch office or your corporate data center to AWS, it can go through multiple hops and through multiple networks that we don't have control over, right? So it's a public internet. Now that may or may not give you performance that you may be needing for your branch connectivity. So one option is to enable acceleration for your VPN connection if you are trying to connect, if you are terminating that VPN connection on a transit gateway. Now in this case, as you can see in the diagram here, you have a branch office in New Jersey. So when you enable acceleration for your site-to-site VPN connection, what it does is that it goes through the local ISP to connect to the nearest edge location and uses AWS Global Accelerator to route traffic from that edge location to the AWS endpoint of your transit gateway, right? So this traffic that is flowing here is using the AWS backbone, which is congestion-free to route traffic to the VPN endpoint. The another option which we have seen is like a more common option that have customers adopted is to create a transit gateway connect attachment. Now what that means is that, so you have your AWS cloud and you have created these multiple application VPCs, and these VPCs are connected to your transit gateway. However, you also have now the corporate data centers as well as your branch offices on the right here. Now, previous to what customers used to do is that they used to have like a transit VPC solution that would connect their branches as well as corporate data centers, and that had some management overhead of managing that as well as the management overhead involved there, as well as you had to manage those VPN connections. With the launch of Transit Gateway Connect, now what you can do is you can natively integrate your SD-WAN appliances that sits within the third-party SD-WAN hub VPC as shown in the diagram here, and can connect that as a native attachment, which we call it as like a connect attachment, which is nothing but a GRE attachment that runs between the transit gateway and the third-party hub appliance here. And then you can use that third-party, you can use that SD-WAN appliance that is running within the VPC to extend connectivity to your corporate data centers using Direct Connect, and then have the SD-WAN overlay that runs on top of that. Or you can have connectivity to your branches directly over the internet as well, as shown in the pink path here. So let's dive a little bit into this transit gateway connect attachment option. And the first option within that is that when you have the SD-WAN appliance that is running within the VPC. So to help explain how that looks like, so you have your multiple VPCs that are connected to the transit gateway. What you do that is you create a VPC attachment for your Connect VPC, which is where you will be running your SD-WAN appliance, and then use that as your VPC attachment as your transport to carry the connect, to create a connect attachment, which will carry your GRE tunnels between the transit gateway as well between the transit gateway and the SD-WAN appliance here. So this is the GRE tunnel that I was talking about. And once you do that, what you are essentially doing is that you are creating a BGP session on top of that. So you are having like a BGP over GRE in this particular case. And the advantage here is that you can use this to scale and connect to multiple VPCs that are connected to the transit gateway, as well as use that to extend that connectivity to your corporate data centers, either using Direct Connect and run SD-WAN overlay on top of it, or you can have direct connectivity to your branches using the internet gateway using the SD-WAN overlay. So far I have talked about the high-level architecture here. Now let's dive into the routing piece of it. So you have the base architecture that I just talked about. What you do next is that you create what we call it as like a transit gateway CIDR block. So you are basically providing some CIDR block to your transit gateway. Once you do that, what you do that next is that you create the connect peer. We call it connect peer. Think about it as nothing but like a GRE tunnel and the configuration for that GRE tunnel that is required. As a part of that connect peer configuration, what you do that is you have the transit gateway address that will be picked up from the transit gateway CIDR block, and you will have the peer address. So in this case, the peer address is nothing but the address of the SD-WAN appliance that is within the connect VPC. And then you will have these inside IP addresses that will be used to create to set up your BGP session that will flow on top of your GRE connection. So let's look at the routing. So you have your VPC route table where you will say that I want all traffic to route through to the transit gateway, and then the transit gateway will have a spoke route table that will be associated to these spoke VPCs A and B. And what it is essentially saying is that I want all traffic to go to the connect attachment, and then the connect attachment will have a route table that will basically determine when the traffic needs to go to the corporate data center or through the branch offices, either using virtual private gateway or your internet gateway. Once the traffic comes back from your branches or corporate data centers, it then needs to decide where it needs to send the traffic. So in this case, you will see the route of the 192.0.2.0/24 that will basically say that the traffic needs to take the TGW and to send it to the connect attachment. From there, the traffic comes on the transit gateway, and it now has the connect route table, which basically has the two VPC CIDRs for the VPC attachments to go back to your VPCs. Now in this case, for simplicity, I have been using a single SD-WAN appliance within the VPC. But from a high availability perspective, you will still you need to run this environment in a multi-AZ setup. So you do the same things. You have the VPC attachment and you create the connect attachment on top of that will use the VPC as your transport. Then you create two or multiple availability zones within the connect VPC and create your SD-WAN appliances within them. Now in this case, you are then creating the two connect peers and run BGP on top of that to each of those SD-WAN appliances. Now one of the key advantage that you get here is that in this particular configuration, you can also do ECMP. And the way the ECMP works here is that you can have the ECMP between the transit gateway and the connect peer on the other side. And it can either do support between the two different connect attachments or two different between the connect peers on the same transit gateway. And you can use that to extend back that connectivity to your data center and branches. However, there is another option here when you have the SD-WAN appliance that is sitting on your corporate data center. The only difference here is that now instead of having the VPC as your transport, you are now having your Direct Connect gateway as your underlay, and then you can have the same setup as you saw before, where you will have the GRE tunnel between the transit gateway and the data and the appliance that is sitting on the on-prem. Now, in terms of routes, you get a higher route limit. From on-premises, you can advertise up to 1,000 prefixes, and from AWS, you can advertise up to 5,000 prefixes. Some of the scaling considerations to keep in mind here is that the bandwidth that is supported on a transit gateway peer basis is 5 gigs, and you can have up to 4 such connect peers, so giving you a total of 20 gigs of bandwidth. And the maximum packets per second that is supported on a per connect peer basis is 300,000 packets per second. So far we have been talking about connectivity to your branches as well as to your on-premise, to your data centers. We have seen customers building a global connectivity. So today, the customers who are doing that, they are likely having multiple VPCs within the single region connected to the transit gateway, and they keep doing this with multiple VPCs and multiple transit gateways in all of the other regions. What they next do is that they create is like a full mesh of the peering attachment. Now in this case, while this works for the customers, as you know, the transit gateway peering attachment today only supports static routing. So what that means is that if you add a new VPC and it needs to connect to another VPC in the other region, you likely have to create multiple static routes to facilitate that communication. We launched a service last year called a Cloud WAN. What Cloud WAN does is that it replaces that VPC, the transit gateway peering attachments, and you create this, what we call it as like a global network, in which you create a core network edge that spans across in this topology. So what you do that next is that you create then these network segments. So you can have your shared services segments, your engineering segments, and your sales segments. And then you can also extend that connectivity back to your corporate data centers using VPNs or your transit gateway connect option that we talked about. And then you can have these segments and build this global segmentation, right, that spans across multiple regions. So this feature is available in public preview today. What that means is that it is not intended for production use today. Once it is generally available, you can start putting your workloads in production. Now, with Cloud WAN, what it does is that the next thing that it does is that once you create these segments, you then now have the ability to connect your VPCs and attach these VPCs to different segments and determine whether you want to have the connectivity between different segments, as well as, and this is possible using a single centralized network policy that comes with the Cloud WAN. So what are the use cases for Cloud WAN? You can use that to connect your VPCs, or you can connect it or extend that, simplify your WAN connectivity there, or you can do a mix of both, where you have the VPCs as well as your hybrid connectivity using VPNs as well as your SD-WAN appliances. So we talked about Cloud WAN, and Tom previously mentioned about Site Link. So what are the use cases for this? So what we have seen customers is that the AWS Cloud WAN is mostly used for customers when they are having VPC to VPC connectivity, or through their hybrid or WAN connectivity through VPN or SD-WAN appliances. And you can build these network segments that determine who can talk to who. With AWS Site Link, if you're already using Direct Connect today, what you can do is that you can do port-to-port connection using Site Link, which Tom just explained about. And it is not dependent on regions because the traffic is not going to the regions. And it supports up to 100 gigs of connectivity. And both of these options, as you can see, they use the AWS backbone. You can have the encryption as well. Now let's talk about the last piece of the network transformation pillar, which is connectivity to remote users. In this option, what you're essentially doing is that you are using AWS client VPN, and you have your remote users that are either using an OpenVPN client or an AWS provided client as well, which we launched some time back. So you have your AWS region, and within that, what you create is what we call it as like a target VPC in multiple availability zones and having multiple subnets. Now, in the next thing, what you do that is you create a client VPN endpoint. And what it does is that then it associates that target VPC to that client VPN. And when you do that, it creates elastic network interfaces within each of that subnets. And before you provide access to your resources, what you can do is that you can do authentication of your users. And there are various options that are available here for the authentication. You can do mutual authentication using Certificate Manager, or you can use user-based authentication where you can use Active Directory or SAML for user federation. So even before providing or authorizing your users to connect to these resources, we launched a new capability which we call it as like a client connect handler, which is nothing but a Lambda function that you run to do the posture assessment for your client. So you can do things like whether the client, which IP addresses the clients are coming from based on what their geolocation is, or if you want to make sure that the client is meeting the minimum requirements for your operating systems. Once you do that, then your remote users can connect to the client VPN endpoint. And you can use this architecture to scale to multiple VPCs that might already be connected to the transit gateway, or you can also have the connectivity back to your on-premises environment as well using VPN or Direct Connect. Once you have this whole setup, you may want to be thinking like, how do I make sure that who is authorized to access my resources? So you have something called as like authorization rules, and these help you to determine which users should be connecting to which target resources on our end, and make sure that you are not allowing like everything to every, you are not allowing all the access to everyone if that's your use cases. So quickly talking about the best practices for client VPN. So as I mentioned, you can use authorization rules to determine and restrict access to what part of the network that you want your users to access. We use longest prefix match, so make sure that you are using that as a evaluation criteria when you are setting up these authorization rules. You can use security groups. You can also use client certificate revocation list if you want to revoke access to the client VPN endpoints for your specific user. So for example, if you have a user who left the company, you want to revoke that access, you can use client certificate revocation list for that. And you can also monitor your client VPN endpoints using CloudWatch, which is what we recommend you. So far we talked about the various pillars of the network transformation, and we have touched on mainly on the connectivity to your data centers, as well as connectivity to your branches, and I briefly touched upon the connectivity within AWS using Cloud WAN. And we discussed various connectivity options that are available to you in each of these to connect your data centers, your branches, your remote users to AWS using the best practices. And that brings us to the end of this session. So we do have 500 plus free digital courses that are available to you that you can leverage to help upskill and sharpen your cloud skills. And you also have the AWS certifications that you can take also. So feel free to take or scan these QR codes if you would like. And that brings us to the end of this session. So thank you for watching this session today. I hope that this session was useful and informative to you. And we would love to hear your feedback on this session, what you enjoyed, what you would like to hear more about this session. So please feel free to take the survey and let us know what we can do better when we come back next time. Thank you very much.